Welcome to another edition of Constellation Friday. Today, in honor of the late and great Hammy Plotner, we take a look at that fishiest of asterisms, the Dorado constellation. Enjoy. In the 2nd century CE, Greek-Egyptian astronomer Claudius Ptolemaeus aka Ptolemy compiled a list of all the then-known 48 constellations. This treatise, known as the Almagest, would be used by medieval European and Islamic scholars for over 1,000 years to come, effectively becoming astrological and astronomical canon until the early modern age. Since that time, many additional constellations have been discovered, such as Dorado. This southern constellation, which was discovered in the 16th century by Dutch navigators, is now one of the 88 constellations recognized by the International Astronomical Union (IAU). It is bordered by the constellations of Coelum, Horologium, Hydrus, Mensa, Pictor, Reticulum, and Volans. Name and meaning. Because of its southerly position, Dorado was unknown to the ancient Greeks and Romans, so no classical mythological connection exists. However, there are some very nice tales and history associated with this constellation. The name Dorado is Spanish for mahi-mahi, or the dolphin fish. The mahi-mahi has a opalescent skin that turns blue and gold as the fish dies. Image of the night sky taken at the European Southern Observatory's Very Large Telescope in Chile. The Large and Small Magellanic Clouds are visible in the night sky. Credit ESOY. This may very well be the reason Dorado is sometimes called the goldfish is certain stories and legends. Because the early Dutch explorers observed the mahi-mahi chasing swordfish, Dorado was added to their new sky charts following the constellation of the flying fish, Volans. Some very old star atlases refer to Dorado as Zephyrs, another form of swordfish, but clearly its fishy nature stands. History of observation. Dorado was one of 12 constellations named by Dutch astronomer Petrus Plancius, based on the observations of Dutch sailors that explored the southern hemisphere during the 16th century. It first appeared on a celestial globe published circa 15,978 in Amsterdam. Dorado was taken a bit more seriously when it was included by Johann Bayer in 1603 in his star atlas, Uranometria, where it appeared under its current name. It has endured to become one of the 88 modern constellations adopted and approved by the International Astronomical Union. Notable objects covering 179 square degrees of sky, it consists of 3 main stars and contains 14 Bay-Flamsteed-designated stellar members. Dorado has several bright stars and contains no Messier objects. The brightest star in the constellation is Alpha Doradus, a binary star that is approximately 169 light-years distant. This binary system is one of the brightest known, and is composed of a blue-white giant classification AOIII and a blue-white subgiant B9IV. The Tarantula Nebula NGC 2070, located in the southern Dorado constellation. Credit ESO Beta Doradus, the second brightest star in the constellation, is a Cepheid variable star located approximately 1,050 light-years from Earth. Its spectral type varies from white F-type to yellow G-type. Like our Sun, Gamma Doradus is another variable, which serves as a prototype for stars known as Gamma Doradus variables, and is approximately 66.2 light-years distant. Another interesting character is HIO 437539, an unbound hypervelocity star in Dorado discovered in 2005. This star appears to be receding at the speed of 723 km 449 ms, and is therefore no longer gravitationally bound to the Milky Way. It is approximately 200,000 light-years distant and is a main sequence star belonging to the spectral type BV, a white-blue subdwarf. Most notable is the Large Magellanic Cloud LMC, an irregular located in the constellations Dorado and Mensa. This satellite to the Milky Way is roughly 1,100 times as massive as our, with an estimated 10 billion times the mass of the Sun. Located about 157,000 light-years away, the LMC is home to several impressive objects, like the Tarantula Nebula and the Ghost Head Nebula. There are no meteor showers associated with the constellation. The Ghost Head Nebula NGC 2080. Credit as Anas Muhammad Hadi Malayari. Finding Dorado. The south ecliptic pole lies within Dorado and it is bordered by the constellations of Coelum, Horologium, Reticulum, Hydrus, Mensa, Volans and Pictor. It is visible at latitudes between 20 degrees and 90 degrees and is best seen at culmination during the month of January. Let's begin our explorations with binoculars and Alpha Doradus, the A symbol on our map. One of the reasons this star shines so brightly is because it's not one, but two. Don't get your telescope out just yet, because Alpha is separated by only a couple tenths of a second of arc, and both members are about a magnitude apart. Located about 175 light-years away from our solar system, this type pair averages a distance between each other that's equal to about the same distance as Saturn from our Sun. That's not particularly unusual for a binary star, but what is unusual is the primary star. Alpha Doré's spectrum is peculiar, very rich in silicon. It seems to be concentrated in a stellar magnetic spot. Let's have a look at Cepheid variable star Beta Doradus, the B symbol on our map. Beta is an evolved supergiant star, and every 9.942 days it reaches a maximum brightness of magnitude 3.46, then drops to magnitude 4.08. While these types of changes are so slight they would be difficult to follow with just the eye, that doesn't mean what happens isn't important. By studying Cepheids we understand period-luminosity relation. The pulsation period of a Cepheid gives us absolute brightness, and comparing it with apparent brightness gives us distance. That way, when we find a Cepheid variable star in another, we can tell just how far away that is. Now, let's go from one end of the constellation to the other with binoculars as we start with Delta Doradus, the 8 shape on our map. If you were on the Moon, this particular star would be the South Pole star, just like Polaris is to the north on Earth. Sweep along the body of the fish and end at Gamma Doradus, the Y shape on our map. Guess what? Another variable star, but this one isn't a Cepheid. Gamma Doradus variables are variable stars which display variations in luminosity due to non-radial pulsations of their surface. The stars are typically young, early F or late A-type main sequence stars, and typical brightness fluctuations are 0.1 magnitudes with periods on the order of 1 day. This is a relatively new class of variable stars, having been first characterized in the second half of the 1990s, and details on the underlying physical cause of the variations remains under investigation. We call these mysterious strangers oscillating blue stragglers. Don't put away your binoculars yet. We have to look at our Doradus. Here we have a red giant mirror variable star that's about 200 to 225 light-years away from Earth. The visible magnitude of our Doradus varies between 4.8 and 6.6, which makes the variable changes easy to follow with binoculars, but when viewed in the infrared it is one of the brightest stars in the sky. However, this isn't what the most interesting part is. With the exception of our own Sun, our Doradus is currently believed to be the star with the largest apparent size as viewed from Earth. The stellar diameter of our Doradus could be as much as 585 million kilometers. That's upwards to 400 times larger than Sol, yet it has about the same mass if placed at the center of the solar system. The orbit of Mars would be entirely contained within the star. Too cool. Dorado contains a huge amount of deep sky objects very well suited for binoculars, small and large telescopes. So many, in fact, our small star chart would be so cluttered that it would be impossible to read designations. One of the most notable of all is the Large Magellanic Cloud, one of our Milky Way galaxy's neighbors and members of our local group. In itself, it is an irregular dwarf, distorted by tidal interaction with the Milky Way, and may have once been barred spiral galaxies. The Magellanic Cloud's radial velocity and proper velocity were recently accurately measured by a team from the Harvard-Smithsonian Center for Astrophysics to produce a 3D velocity measurement that clocked their passage through the Milky Way in excess of 480 km 300 miles per second using input from Hubble telescope. This unusually high velocity seems to imply that they are in fact not bound to the Milky Way, and many of the presumed effects of the Magellanic Clouds have to be revised. Be sure to explore the LMC for its own host of nebula and star-forming regions. It was host to a supernova SN 1987A, the brightest observed in over 3 centuries for the telescope. There are many objects in Dorado that you don't want to miss. This article would be 10 pages long if I listed them all, so let's just highlight a few. For group fans, why not choose NGC 1566 RARO 4H 20 meters ODEC 56.3. NGC 1566 is a spiral that dominates the Dorado group, and it is also a safe bet as well. At the center of the cluster, look for interacting galaxies NGC 1549 and NGC 1553. These two bright members are lenticular NGC 1553 RARO 4H 16 meters 10.5 S-Dec 55 46 feet 49, and elliptical NGC 1549 RARO 4H 15 meters 45.1 S-Dec 55 35 feet 32 inches. Their interaction appears to be in the early stage and can be seen in optical wavelengths by faint but distinct irregular shells of emission and a curious jet on the northwest side. Chandra X-ray imaging of NGC 1553 showed diffuse hot gas making up 70% of the emissions, dotted with many point-like sources, low-mass X-ray binaries making up the rest. Similar to Messier 60, these bright spots are binary star systems of black holes and neutron stars, most of which are located in globular clusters and reflect this world's very active past. In these systems, material pulled off a regular star is heated and gives off X-rays as it falls toward the accompanying black hole and neutron star. The location of the southern constellation Dorado. Credit IOSCI Telescope magazine. Turn your telescope towards NGC 2164 RARO 5H 58 meters 53 S-Dec 68 30.9. Here we are resolving an open star cluster, globular cluster that's in another. Folks, also nearby you'll find faint open cluster NGC 2172 RA 559.9 Dec 68 38 and galactic star cluster NGC 2159 05 57.8 68 38. What a treat to study in another. Would you like to study another complex? Then let's take a look at NGC 2032 RARO 5H 35 meters 21 S-Dec 67 34.1. Better known as the Seagull Nebula, this complex that contains four separate NGC designations: NGC 2029, NGC 2032, NGC 2035 and NGC 2040. Spanning across an open star cluster, there are many nebula types here, including emission nebula, reflection nebula and HII regions. It is also bisected by a dark nebula, too. Of course, no telescope trip through Dorado would be complete without stopping by NGC 2070 RARO 5H 38 meters 37 S-Dec 6905.7, the Tarantula Nebula. Located about 180,000 light-years from our solar system and first recorded by Nicholas Louis de Lacaille in 1751, this huge HII region is an extremely luminous object. Its luminosity is so bright that if it were as close to Earth as the Orion Nebula, the Tarantula Nebula would cast shadows. In fact, it is the most active starburst region known in our local group of galaxies. At its core lies the extremely compact cluster of stars that provides the energy to make the nebula visible. And we're glad it does. We have written many interesting articles about the constellation here at Universe Today. Here's what are the constellations, what is the zodiac, and zodiac signs and their dates. Be sure to check out the Messier catalog while you're at it. For more information, check out the IAU's list of constellations, and the Students for the Exploration and Development of Space page on Canes Venatici and constellation families. Sources: Tammy was a professional astronomy author, President Emeritus of Warren Rupp Observatory and retired Astronomical League Executive Secretary. She's received a vast number of astronomy achievement and observing awards, including the Great Lakes Astronomy Achievement Award, R.G. Wright Service Award, and the first woman astronomer to achieve Comet Hunter's Gold status. Tammy passed away in early 2015. She will be missed. 88 IAU constellations: Almagest constellations, Dorado constellation, featured Ptolemy.